In the last lesson, we examined how we can collect algebraic terms to make them simpler. Right? Finding things that were like, same letters, the same exponents can be collected together. Today we're going to look at what happens when we multiply things that have letters in them. The big idea here is that we can use exponents. And to do that, though, we have to remind ourselves what an exponent is. And all it really is a faster way of writing something out when something is multiplying by itself. So for instance, 2 times 2 times 2 times 2 times 2 times 2, who wants to write all that out? It's way faster to write it as 2 to the power of 7. We know that's the same thing because it's the same number 7 times. Okay, so we try a couple of these just to get our brain warmed up a little bit here. I have 3 times 3 times 3 times 3 times 3. Faster to say 3 to the power of 5. There are 5 3's being multiplied together. In B, we've got the number -4, and we've got it 4 times. Now, if we were to write this down, it actually wouldn't be right, because the 4 exponent is not acting on the negative sign right now. I need those brackets in there to remind myself I need 4 -4's. And if we try C, 2 times 2 times 2 times 2 times 2 times 2. Well, if I stop and think about this, really I have 7 2's. Those brackets, they're kind of in there to trick us. Okay, do we really need the brackets there, or is it just another way of showing multiplying? I think it's just another way of showing multiplying. It's a 2 to the power of 7. But what is really happening here is this part here, that's 2 to the power of 4. And this part over here is 2 to the power of 3. And if I multiply those two things together, well, if I look at the 4 and the 3, doesn't that make 7? And that's kind of our key idea for when we do algebra with exponents. If you have things that are the same base, in this case, your 2's, and they're being multiplied, well, you can simply add your exponents together to figure out the new exponent. Okay, so let's take a look at these ones. 3 to the power of 3 times 3 to the power of 2. What does that really mean? It means 3 times 3 times 3 times 3 times 3. Well, isn't that the same thing as saying there are 5 3's being multiplied together, just showing different ways of multiplying between them? Or as we can look, 3 and 2 makes 5. How can you do the next one? 2 to the power of 4 times 2 to the power of 5, that's 4 2's, multiplied by 5 more 2's. Well, that's simply 9 2's. Right? Or in other words, 4 and 5 added makes 9. Kind of the big key idea. Okay, it's pointed out for us. If we have bases are the same, that's a big one there. Bases have to be the same. I couldn't do this idea when I've had things like this, because my bases are different from each other. There's no rule there. And they're being multiplied, which we have. And multiplying could be shown with a times sign. It could be shown with brackets. Well, the fast way of doing this is just to simply add your exponents, as we pointed out in those last 3 questions here. Let's try a couple. 2 to the 7 times 2 to the 4. So 7 2's times 4 2's. Well, that's the same thing as saying I've got 11 2's. And add my exponents together. My bases are the same, and they're being multiplied. 3 to the 4 times 3 to the 5. Well, that's a whole bunch of 3's. How many? Well, 4 and 5 makes 9. X to the 4, x to the 7. Here comes the algebra stuff. Are our bases the same? Sure they are. They're both x's. So my base is an x. And how many of them do I have? I've got 4 here and 7 here, makes 11 x's altogether. Right, x to the 3, x to the 8, same bases, multiplying, x to the 11. 2 to the 3 plus 2 to the 4 is, bases are the same, but I'm not multiplying. If I'm not multiplying, I can't use that rule. The rule was it has to be multiplying. So what do I have to do instead? This is a trick question. I have to go back to BEDMAS, since it's adding. or subtracting. Anything that's not multiplying, I can't use this rule. How does BEDMAS work? Well, brackets exponents. 2 to the power of 3 is 8 plus 2 to the power of 3 is 8. That answers 16. Yeah, that's a trick question because it has a plus sign in there. Remember our two rules. Same bases, which was okay in this case, but also multiplying. Okay, let's take a look at F. Ooh, F is messy looking. I got X's and Y's and X's and Y's. Well, kind of the cool thing about multiplying is the order you multiply in doesn't really matter. So I can put the X's with the X's. So I got 3 and 2. That gives me 5 X's being multiplied together. And I can put the Y's with the Y's. How many Y's do I have? Here's a little trick for us in this case. We definitely see the 5, but what's on the other Y? What's on this Y? How many Y's are there over there? Well, like with other algebraic things, if you don't see a number, you can always put the number 1 in there. So we actually have 6 Y's. And it helps to put the 1's in when you're not sure what number's there, just like when you collect them. Okay, you guys can try the next one here. A4B times B5C. Okay, A's go with, well, I got no other A's, so I just got 4 of them. B's go with B's, and I need to put a 1 in here to remind me there's a 1 there. So how many B's do I have? I got 6 of them being multiplied. And C, that's one of them. There's nothing for C to go with, so it just stays by itself. If your letters are different, they can't do anything with them. Just stick them beside each other. Which kind of answers our last question here. A to the 4 and B to the 3. Well, that's just A to the 4 and B to the 3 because our bases are different. The rule is same bases and multiplying. In this case, I got the multiplying, but I don't have the same bases. That's as far as I can go. Okay. What happens if we put numbers and letters in there? You have to think about this a little bit more, because that's really how algebraic things work. So you usually have a number out front and some letters beside it. So what do? Well, step 1, for multiplying, multiply the numbers together. Numbers go with numbers. Okay. And letters go with letters. So if you have any exponents on the similar bases, you can stick those things together, like we just did. So let's try some. What do I have here? Oh, 2 times 3. That's what that says. That's 6. Done the number part. Let's look at the letters. What letters do I have? I've only got an X, no other X's, so I've just got an X. That's it. That's all I'm done. If you want to put the 1 on here, you can put the 1 on here. Remind yourself there's a 1 there. Let's look at the next one. 4 times 6, that makes 24. I've got 1x and 1x, and what do I do with my exponents? I add them to get 2. There's my answer. Let's go to the third one. 3 times negative 5. Oh, it's negative 15. Hey, x with x, and there's 1x there. So I've got 3 x's altogether. Y's go with y's. I've got 1 y here and 1 y here, so I end up with 2 y's there. Remember, with exponents, we're adding the exponents, right? We'll try the next set. 2 times 2 makes 4. I got x's, but I have no other x's. I guess I just got my 3 x's. I've got y's, but no other y's. So I've just got my 2 y's. They have different bases. They cannot be combined together. They're different letters. Try the next one here. 3 times 2 makes 6. I've got 2 A's and 1 more A, which gives me 3 A's. I've got 1 B and another B, which gives me 2 B's. The next one, 2x cubed plus 7x squared. Oh, I said that magic word, right? Plus. We know if things are plus, we can't use the rules we've been talking about. Plus goes back to BEDMAS. BEDMAS says brackets, exponents, division, all that fun stuff. This actually goes back to a question from yesterday. How do I add things together? I can only add if they're like terms. Like means same letter, yep, got x's, but also same exponents, and they aren't. So what can I do with this question? Absolutely nothing. And they cannot be collected because they're not the same kinds of things. Some of them are circles, some of them are squares. Different kinds of shapes, different kind of exponents. And the last one. Stick it together. Oh, numbers, numbers, numbers. Oh, I gotta put a number up front to remind me there's a 1 here. 1 times 2 makes 2. A's. Oh, I got one A and another A, and A times A makes 2 A's. B's and B's. I got 2 and 2, that makes 4. C's go with C's. I got 3 and 2, that makes 5. There's my expression. 2a to the power of 2, b to the power of 4, c to the power of 5. Okay, and that's it. As far as I can go with that thing, because there's nothing left to do with it. Okay, that takes us to the end of the lesson. Okay. We're going to try this sheet on the website, just to point out how this one works. It's slightly different than normal. It's not just like a fill it in and get the answer. And the sheet on the website looks like this. And the way it works in here is we're going to try and solve the problem. And a dot, you can come across it like right here. It means multiply in the first question there. So what we'll try, let's see if we can write on here, dot, right there. See there's a dot? That means multiply. So how does this work? Well, x2 to the power of x4 comes out to x to the power of 6. We're going to find that answer, which is right here. And then, see how there's an 11 right here? In box 11 at the bottom, we're going to put the letter T. So 11 is T at the bottom. Apparently won't let me write down there, down here. Okay. Try the next one. We would do x to the 3 times x to the 7. That comes out to x to the 10. And we'd find x to the 10 down here. So in box number 15 at the bottom, you would put the letter E this time. And so on and so on. Until the whole box comes in. When you're done, you get the thing at the bottom is going to answer this question. Why is a lame elephant like adding 19 and 4? And it's going to be a really silly joke, okay? That's what's going to happen down here at the bottom. Some sort of really silly joke. It won't let me write in the bottom for some reason, so just to put up, this would be the letter T down here. And E would be in box 15, so there'd be an E in that box there. And so on and so on. Okay, give it a try. See how you can do. If you're stuck, come see me. Save.